Hey guys, welcome back to the channel. I hope you all are doing well and fine. And in the last video, we discussed about the topics, which were the selection statements or the conditional statements. Then we studied the iterative statements, and lastly, the jump statements. I hope that much is clear to you. In today's video, we will be covering our new topic, which are the functions, and we will be seeing some practical implementations of the same. So I hope that you will be understanding each and every concept. So let's get started by today's discussion.
Starting with our today's discussion, what are the functions at the first place? So, function is a group of code or a block of code which is reusable. If you write it performs a specific type of operation. Like if you want to perform multiplication, you can just write a particular function for the same, and you will have to call the function again and again. So you don't have to type the code again and again to just perform a single operation. That makes your code reusable, and it increases the readability of the code as well. So this is one of the advantage of using a function. And whenever you write a function, it always starts with def keyword, which means you are defining a function. It is the definition of a function. Here in this example you can see def greet. This greet is the name of the function, and the function what the function is performing, it is printing hello there. So function is performing hello there, and if you this greet again 2 times we wrote, it is the calling of a function. Whenever you call this function, it will perform the operation. Here we have printed hello there and we called greet. So our one output is hello there, and again we called the same function greet, then we again got the same output hello there. So this is how the function works. Here you can see def starts a function definition and code runs only when the function is called. Like if you don't call the function, like you don't call the greet here, your code will not be executing, and the same function can be called multiple times. Like if you want to perform the same operation but on the another values, you can perform the same function again and again. So this is how it increases the code's reusability, and you don't have to write the bulky codes again and again. So your coding, it won't look so much messy and it would be easier to understand. So these are the advantages of why to use the functions. I hope this much is clear to you. So now next we will see the parameters, arguments, and default arguments which we use in the function. So what are the parameters and arguments? In this example you can see here def is the definition of the function, and again add is the name of the function, and whatever values you will be writing inside this parenthesis while defining the function, these are what known as the parameters of the function. And this is the performing operation, it is performing, the function is performing. And then we again call the function add, and the values we will be giving here inside this function, inside this calling, these are the arguments. So I hope this difference is clear to you. Arguments are the actual values that you pass to the function here. These are the actual values which you pass in the function, whereas parameters are placeholder in the definition. It just defines the number of arguments a function can take. If you don't specify, that function will not be taking any arguments from you. Then we have the default arguments. Like in some case when you don't provide any specific value to the function, here the default value is given by itself. See, name equals to guess. Like if you don't provide any argument here, so the output by itself, it would be the guest. Here hello guest is printed. But if you provide some sort of arguments to it, like here we have provided Aditi, so in the final output we have got hello Aditi. But the default arguments helps you when you don't have any specific arguments, and you want to perform the same operation. So it somehow makes your code a little bit user friendlier. Code it increases the readability of the code. Then we will be moving forward to our next topic, which is the return statement. See, it is one of the most important topics in the function. Why? If you don't provide any return statement, your function will return you nothing. Like if you are printing, that's a different case. But if you don't write the print function and also don't write the return operation, your function will return you none. None. It is another data type in Python. So to avoid those kind of circumstances, you need to use the return statement. So in our example, we have written a function to define the square of a particular value. So here it is taking one parameter and it is returning the square of the same value, of the same parameter value. And then we are giving the calling of the function to this variable, this is the variable which you are giving the calling of the function. And if you don't print the result, your output will not be printed. Why? Because in the square function, we didn't give the print statement inside the function itself. So if you don't give the print statement, your function will not get printed by itself. So to print your function, you have to print the calling of the function. Without that, you cannot print your function. So if you want to get the output, only the return statement is not enough. See, if your function is returning some sort of output, you have to use the return function. And if you are printing the same output returned by this return function or directly just print, then you don't have to again write the print function. But if you don't have written the print function inside the function itself, you will have to write this print function. It is a must because without that you cannot get any output on your output shell. So I hope this is clear to you. Then we have the variable scope. So inside the function, like in Python, the functions, the variables are of two types. The scope of the variable are two, that is the local variables, and secondly we have the global variables. So what is the difference between the local variable and the global variable? See, if a variable that is defined outside a function, like you know how you define a function, like using the def keyword, then the name of the function and the parenthesis. If you write any variable before that, that will be defined outside the function. So that this variable, it would be a global variable, which means if you use that variable inside a function, it will be alright, it won't give you any sort of error. But unlikely the local variables, these are the variables which you define inside a function. Like here, y is a local variable. Why? Because we define that variable inside our function. The show function is having the variable y equals to 5. So here, if you use this variable outside the function, it will give you an error. But if you use this x variable inside the function, like we are using here in the print statement xy, it won't give you any sort of error. Why? Because x is a global variable. It can be used inside the function, outside the function. It doesn't matter. Like it don't give you any sort of error. But in the second case, when you have the local variables, you cannot use those variables outside the function because these are defined within the function only. So their scope is the function scope, whereas the another global variable having the global scope. So it can be used anywhere in your Python code, and unlikely the local variable, it cannot be used anywhere. It will be useful only when you will be using it inside your function. I hope local and global variables difference is clear to you. Now we will see some practical implementation of all the topics, all the functions we have discussed by now, and I will show you some implementations or example codes, like the multiplication code you can have. You will define the code in a function itself and you will be using it multiple times for the different values. So we will see the same. Let's get started with our implementation parts of the video. Now we will be writing our first code, which is the multiplication code using the functions. So first of all, you will define the function using the def keyword, then the name of the function. I'll give it prod, and we will give some parameters x and y, let it be. And don't never forget to use this semicolon, which is a must in Python. And then we will give another variable, the output, x into y. So it will return the product of the two variables, and we will return this into the return statement. And now, so you will have to give the parameters or the arguments to your function. You can directly just give the arguments like prod and any value like 3, 4 I have given, and we will give this calling to another variable, and we will print that variable because we didn't write our print function inside the print keyword inside our main function. So we will have to write the print statement again. It is also known as the output statement as well. And we will execute this code and see directly we got the 12 as our output. So you can perform this operation by doing it like this, like giving the value by yourself. But if you want to give the user defined values, you can do it that as well. You can have two variables, like I will take a int input enter value, another variable b input enter value. Now you will give the argument as a and b, which are now the user defined arguments. So it will take the values from the user, like 5 I will do and 8, and see I have got 40 as my output. So you can see how this makes our working so much easier. Like you don't have to type same code again and again to perform the same operation. You can also perform many other operations, like if you want to count a number, particular element present in our string, or how many times a particular character is present in our string. You can also perform that operation by using the functions only. Count, and we will give one parameter which value you want to count, and here count. We cannot give the name of the function as a keyword, like count is a keyword. So we will write count occurrence, and also we will have to specify the string in which you want to find the number of occurrence of a character. You can do this operation by using the looping statements, like for I in s. If I is equal to n, so you will have to also define another variable count. So it will be helping you count the occurrence of a particular character. Now, if you find the element like a character which you want, you will increase the number of count by 1. So it is count plus 1, and we will return the count. And now, since we have given two parameters, we will have to take the two user inputs, or it's your choice if you want to give the user want to give the arguments by yourself. It is your choice. But making the function user, like giving the user defined functions like variables, it helps help you increase your code usability, or make your code user friendly. So we will take the input as strl input enter a string, and then the character input perform, we will call the function. Like we have not given the print statement again, we will have to give the result to another variable, and we will call our function count occurrence, and we will give the input as argument as strl and ch, and we will print our result. And we will execute this code. Hello world. And see, in our string, the number of occurrences of L is 3 times. Like L is occurring for 3 times in our string, which is, you can see here, double L, and 1 in the world as well. So this is one way you can perform the count operation. You can also directly just use the count function in your inside a function. Like again, I will perform count occurrence, again S and N, and I will directly just use the count function s.count n. Like I told you in the strings concept, like if you didn't watch that video, you can go watch that video first. We have discussed several functions or inbuilt function in the strings, and one of the functions, inbuilt function, was the count function. So I hope you remember the concept. And we will take the user input again, s1 input, enter a string, and again the character ch, input, enter character. Now we will give the calling to another variable, count, and s1 and ch. We will print this variable. Hello Python. And see, the same working using the count function. Means instead of writing the whole big code using the for statement, for loop, you can just directly use the count method or count function as well to perform the same operation. I hope this is clear to you. And now we also saw another topic, which was the variable scope. So we will see the execution of the same as well, like this. X equals to 10. We defined a global variable, and we will be using this variable inside the function, and also we will see the local variable. We will try to use that local variable outside the function, and you will see the difference. Def variable. We will print s plus y. We will define the y. Y equals to 20, and we will just call our function variable. We will comment this out again, and see, here we got our output. Why? Because x is defined outside. But if you use this function, like we have defined print, like here y equals to 20, and if we print y, if you will print y, you will see here y is not defined, so it has given you an error. it is a name error, which means we have not defined the y in our code. This is how it specifies the scope of the variable, and you cannot use the local variables outside the function, and global variables, these can be used anywhere. Like if I print x, it will not give you any sort of error. In here we'll comment this out and we'll just print the x, and see here x is printed. So I hope this is clear to the concept of local and global variables. Our next topic of today's discussion are the modules, and it is one of the another important topic. Why? Because it somehow makes your work a little bit easier. Like if you want to perform the operation, like you want to perform the square root operation or cube root operation, you want to find the any value that is the like the seal value or the floor value, you can use the math module. Or like this is how there are several modules which somehow makes the work easier by performing the inbuilt operation by themselves. So I hope this much is clear, and now we will be starting with our new topic, which are the modules. Now moving towards our next topic, which are the Python modules. So what are modules? In the first place, module is a file of code, like a Python file, in which you write the codes of Python, and instead of writing the same code again and again, you can directly just import that same file and perform the particular operation you want to perform. And again, in the types of module, you have two types. Like one is the inbuilt, like we have math and a random module. Like these are inbuilt modules which are present in Python, but there are also the second type, which are the user-defined module. Like whenever you create a file using the .py extension, it is a Python file, and also it contains some sort of code you have written by yourself. If you import that file, that also works as a Python module and is a user-defined Python module instead of a built-in one that Python provides you by themselves. So how you can use a module? You can use a module using import function. You can import all the functions of a particular module using the import keyword. Here we have used import math. So all the functions which are present in the math module are now applicable. That means you can perform any sort of operation using the math module. Like here we have performed the square root operation. Like we have found the square root of 16 number, and the square root of the same is 4. So we have got the square root of 16, that is 4. And same way we have printed the value of pi using the math module, which is the 3.14 and so on. So this is how you can perform the operations directly just by using the math module or using particular module. These somehow makes your code like a little bit reusable, and instead of writing the whole code again and again, you can just directly write everything from the scratch. There is another built-in module, which is the random module. It helps you giving a approx value. Like if you want a value between 1 to 10, you can use the randint function. It will give you any value it can give you, but between the 1 and 10. It will include both 1 and 10 as well. And there are two other functions or methods you can use inside the random module, which is the rand range and random. The random one, it gives you any decimal value from 0 to 1. It don't even specify any range, like you don't need to give any parameters. Its default parameter is itself 0 and 1. It don't take any other parameter or any argument. Then we have the rand range. The difference between randint and rand range is that randint includes both the values, like from lower parameter as well as upper parameter. both the limits are included. In case of rand range, only the lower limit is included and upper limit is excluded. So that's the only difference. Other than that, both of the function returns the any integer value between the given ranges. So now we will see some implementation, and I will show you all important necessary functions which are present inside the math module and how you can use and perform your desired operation using the same. So here, these are some basic functions which we have in our math module. We will discuss these one by one. So first of all is the square root function, like you already know, like I have given you an example, like any argument inside this, it will give you the square root of this argument. We also have the same for the cube root as well, that will be CD RT, and it will give you the cube root of a function of a variable which you have given inside the parenthesis or the argument. I'm sorry, the accurate word for that, for this value, it is the argument or a parameter. Like if it's used while defining the function, it is known as the argument. But once it is like we are providing the value to that function, now we are providing the value to this function, so it is the argument. Then second we have the power function. See here x, it means x raised to the power y. The meaning of the term is x raised to the power y. So this function will return you the value of x raised to the power y. Then we have factorial function. Factorial is a mathematical operation. Like if you want to get the factorial of 5, that means 5 into 4 into 3 into 2 into 1. So this operation which you perform on 5, it is the factorial of 5. So there is also a code, like you can write the complete code to get the factorial. We will see some codes of the same as well. But if you don't want to perform all these logical things, logical methods, you can directly just use the factorial function under the math module. Then next we have the ceil function. It gives you the round of value, like you will be providing some decimal values inside the argument as an argument, and whatever will be the value next to that argument, it will be written as your output. Like if you have 4.9, your output will be what? Your output will be 5. Okay, I hope this is clear. If you will provide some negative value like minus 4.9, so what value comes after minus 4.9 in the number line? It is the minus 4. So that one will be your output. Then next we have the floor. Floor operation or floor function returns you round down value, like the same way we did like 4.9. So the integer before 4.9, just the next integer, the before one of 4.9 will be what? 4. So your 4 will be the output. If you write minus 4.9, so before minus 4.9, the integer will be 3. So that one will be your output. Then next we have fabs. It will return you the absolute value. That means if you have any minus negative value, it will return you a positive value in despite of whether you have a decimal value or any other value. It will just give you the positive value, 90.9. It will return you minus 9. It will return you 90.9, not the 90. It will not change the value, like the decimal point or anything. It will just remove the negative sign. I hope this is clear. Then we have GCD, the greatest common divisor. You can give any two arguments and it will return you the greatest common divisor among both of them, the common divisor between both of them. Then we have the log operator. It will return you the logarithmic value of the argument which you will be providing. Then we have three trigonometric functions, the sine function, cos function, and tan function, to return the cosine, sine value, sine, cosine, and tangent value of the particular argument. I hope this much is clear. Then lastly, we have two constant functions as well. If you write math.pi and print that, it will return you the value of the pi. And similarly, the exponentiation. If you write math.e, it will return you the value of exponentiation as well. So we will perform all these one by one. First, to implement any function from the modules, we will have to import the module using the import keyword, import math, and we will print math.sqrt and 64, print math.cv. Our cube root function is not available in here. We will go with another function, which is the power function, power of 2 raised to the power 4, and then print math.factorial. Factorial of 5, it would be 120, and print math.ceil 7.8. We will see the same using the negative value as well, minus 7.8, and again print math.flow 7.8. Negative one, and print fafs minus 78.9, and print gcp 12.24. Sorry, math dot log of 100, and math sine of 60, cos of 0, math dot tan of 45, and math dot pi so now we will interpret all of these one by one. So first of all, we have the square root function. So square root of 64 is 8. So the output of this code will be 8. And then we have power. That means 2 raised to the power 4. That is 2 into 2, that's 4. 4 into 2, 8. And 8 into 2, 16. Similarly, we have factorial 5 into 4 into 3 into 2 into 1. That means 120. Also, the factorial of 0. It is always a 1. So it will return you a 1. We will see that also. The ceil, that is just the next value, that is 8. And here we have minus 7.8, which means the right next value will be minus 7. Here we have 7.8. So just below value, it is 7. And same way, just below value for minus 7.8, it will be minus 8. And for the absolute value, it will be 78.9. It will just remove the negative symbol, the minus sign, and the greatest common divisor, which we will see by the execution only. And the logarithmic value of 100 is 10. In the same way, we will see, and here again we will see the output. See, first we have 8, 16, 120, 8, minus 7, like I told you, minus 8, 78.9, 12 is the greatest common divisor again. Okay, and the logarithmic value of 100 is not 10, it is 4.605 something. No, wait, we missed something. The sign of 60 is this, minus 0.30481 and so on, and the cos of 0 is always 1. The 10 of 45 is 1.619 and so on, and same way we have the value of pi as well as the e operator. So I hope this much operation it will be understandable to you. You can also perform the same operation like using the user defined function. Like you will save your file, you will create another file and perform some sort of operations like multiplication or division, subtraction, anything, and you will save that file using the .py extension, which will specify the file is a Python file, and then when you will import the same file and perform the operation directly, you will directly just call the function, it will perform the operation. We will see that as well. I'll create a new file, cal.py, created, and now we will create two functions, add, and it will add the two values x, y, and print x plus y. Now we will take the user arguments. User input, I misspoke, and the value, input, and the value. Now we will call add a, b, and same way we will perform subtraction as well on P and Q, and we will print P minus Q. C input and the value will be equals to int input and the value sub p c d. And now we will save this file. We can also perform the same, we will see the operation here only first. Okay, our addition is working, we have subtraction and it is working. It is giving you the addition and subtraction both. Now we will import this file in our index file using the import function. Import cal and print cal dot add 78 and 10. In the same way, we will print cal dot sub 78 and 10. We will print this. Okay, our file was user defined, so it is taking the input from the user only. You don't have to use the print function because in our here in our function we have already given the print statement. You can directly just call the function. I will just call the function cal.add. We will remove the print sign and the print output statement. You don't even need to give the input arguments because we have given the function as the user defined values. And we will again execute this code. 34 10 again 34 10. Okay, you need to just specify this, and now our code is executing. And see, so even though you don't need to in our this file, if you don't even give the user defined function input, you can just perform the operation here. But if you have given, it's okay. And now you can perform
the addition and
the
subtraction. So guys, that's all for today's video. In this video, we covered the two topics, which were the Python functions and the parameters and arguments which you give into the function. And then we studied the modules, two types, the user defined and the inbuilt module. So in this topic or the topics we have covered in all the videos by now, if you have any doubt, you can do ask and drop out the comments. And if you find this video a little bit helpful, please do like and share. In the next video, we will be covering or we will be starting our new two topics, which are the exception handling and the file handling. So till then, take care. See you in the next video.